Okay, next subtopic for chapter 1 is 1.2 carbohydrates. Okay, as for information, carbohydrates are found widely in both healthy and unhealthy foods such as breads, beans, milk, popcorn, cookies, carbonated drinks, and of course ice cream, as we love to eat it. And carbohydrate is a molecule which involves sugars and polymers of sugars. Okay, there are 4 learning outcomes that you should know for these subtopics. Okay, let's look at the slide. Okay, the first one is you must be able to state the classes of carbohydrates such as monosaccharide, disaccharide, and polysaccharide. The second one is identify the structure of alpha glucose and beta glucose, where alpha glucose and beta glucose is a monosaccharide. And then identify the structure of maltose, which is disaccharide, and identify the structure of cellulose. Okay, that is for polysaccharide. And the third one is describe condensation and hydrolysis, and lastly illustrate the formation and breakdown of maltose. Carbohydrate is organic molecules which compose of carbon, hydrogen, and oxygen atoms. Okay, so the proportions for carbon, hydrogen, and oxygen atom usually 1:2:1 respectively. Okay, for example is C6H12O6. Okay, as mentioned before, there are 3 main classes for carbohydrates: monosaccharide, disaccharide, and polysaccharide. Monosaccharide is the simplest sugar, okay, or single sugar. Disaccharide is a double sugar. Consists of 2 monosaccharides joined together by covalent bond, and polysaccharide is a complex sugar consists of polymers of many sugar. Okay, for monosaccharide, we can divide it again into 3 types of sugar: triose sugar, pentose sugar, and hexose sugar. Example for pentose is ribose and deoxyribose. An example for hexose is glucose, galactose, and fructose. While for disaccharide, the double sugar, example is maltose, sucrose, and lactose. And for polysaccharides, example is starch, glycogen, and cellulose. But for this topic, you should only know the structure of glucose, okay, which are alpha glucose and beta glucose for monosaccharide. And for disaccharide, you should know the formation and breakdown of maltose. And for polysaccharide, you should know the structure of cellulose. Okay, so let's look at the characteristic for each class of carbohydrates. Okay, the first one, let's look at the characteristic for monosaccharide. Okay, monosaccharide is a simple sugar that cannot be broken down into smaller molecule by hydrolysis. And for monosaccharides, it is sweet tasting, soluble in water, it can be crystallized. Monosaccharide is a reducing agent. Why is it a reducing agent? Because it has an open chain with aldehyde or ketone group. And monosaccharide is a monomer for disaccharide and polysaccharide. The general formula for monosaccharide is in bracket CH2ON. Okay, where the N is the number of carbon atoms in the molecules. Okay, so the N can be 3, 4, 5, 6, or 7. Okay, the common example is glucose. Okay, where the general formula for glucose is C6H12O6. So basically, we can say that molecular formula for monosaccharide are in multiple of unit CH2O. And mostly the name for sugars are ended with OSE. Okay. Okay, let's look at the structure of monosaccharide. Okay, monosaccharide, the structure it can be linear, open, or straight chain form, or ring form in aqueous. It has a carbonyl group and many hydroxyl groups. Let's look at to this slide. This slide shows you the two forms of monosaccharide, the linear form and the ring form. Okay, and from this slide you also can see there's carbon bonded to oxygen and hydrogen. So this is carbonyl group, and there's many carbon that bonded to OH, which is hydroxyl group. Same goes to the ring form. You can see many carbon that bonded to OH group or hydroxyl group. Monosaccharide, we can classify it based on the types of functional group. So it can be aldehyde or ketone, okay, by refer to its carbonyl group. And we also can classify monosaccharide by the number of carbon atoms in the back. If the carbonyl groups, which is C double bond O at one end of the molecules, this one and this one, okay, so this is aldehyde group, so the sugar is known as aldose. Okay, if the middles of the molecules, for example, this one is at carbon number 2, so this is ketone group, so the sugar is known as ketose. For the classification of monosaccharide based on the number of carbon atom in the backbone, we can divide monosaccharide to three groups. Okay, triosugar, pentasugar, and hexosugar. So if there's 3 carbon atom in the backbone, it is known as triosugar. For example, glyceraldehyde. For the pentasugar, it contains 5 carbon atoms in the backbones. Example of pentasugar is ribose and deoxyribose. And hexosugar contains 6 carbon atoms in the backbone. Example is glucose, galactose, and fructose. Okay, next is characteristic for disaccharide. Disaccharide is a double sugar which is consists of 2 monosaccharide joined by glycosidic linkage. Okay, disaccharide is sweet tasting, soluble in water, and it can be crystallized. Disaccharide is maltose, sucrose, and lactose. Okay, maltose is a malt sugar. It's formed by joining of 2 alpha glucose. Maltose can act as respiratory substrate. It is a reducing sugar and joined by alpha 1,4 glycosidic linkage. While for the sucrose or cane sugar, it is formed between alpha glucose and fructose. So sucrose is the main form of sugar that is transported in plants. It is a non-reducing sugar and joined by alpha 1,2 glycosidic linkage, and lactose is milk sugar forming from joining of galactose and beta glucose, can act as a source of energy. So lactose is a reducing sugar and formed by beta 1,4 glycosidic linkage. Next is characteristic for polysaccharide. Polysaccharide is a large or complex molecule consists of many hundreds of monosaccharide which is joined by glycosidic linkage. Okay, differ with disaccharide and monosaccharide. The polysaccharide is not sweet, insoluble in water, but it will not affect water potential of the cell, and polysaccharide cannot be crystallized. Examples for polysaccharide is starch, which act as a plant food storage, glycogen as animal food storage, and lastly cellulose as a main component of plant cell wall. Okay, let us identify the structure of alpha glucose and beta glucose for monosaccharide, maltose for disaccharide, and cellulose for polysaccharide. This is the structure of alpha glucose. Okay, if you look at the structure of alpha glucose, you can see that the hydroxyl group at carbon number 1 is below the plane. And this is beta glucose. And for the beta glucose, you can see that at carbon number 1, the hydroxyl group is above the plane. This slide shows you the structure of maltose. Okay, maltose is formed from joining of 2 alpha glucose. Okay, and if you look at here, This is one alpha glucose and this is another one alpha glucose. So both are joined by alpha 1,4 glycosidic bond. Maltose is formed from condensation process between two alpha glucose, where through the process, water molecule is removed and the two alpha glucose is joined by alpha 1,4 glycosidic bond. Then the maltose is breakdown through hydrolysis process. So hydrolysis process involves the breakdowns of water molecule. And this is the structure of cellulose. Okay, if you look at the structure of cellulose, it is a long, straight, unbranched chain. And here you can see the location of oxygen is upside down. Okay, so each of its monomer is linked by beta 1,4 glycosidic bond. So we can say that cellulose consists of beta glucose as the subunits, and the beta glucose monomers are linked upside down to each other. Only one type of linkage involved, which is beta 1,4 glycosidic bond.